And the second bus is AMBA-APB. AMBA-APB bus is mainly optimized for minimal power consumption, and second one is it's having a very reduced interface complexity. Okay, first, these are all the features of this AMBA-AHB bus. First is bus T transfer. In AMBA-ASB also we have bus T transfer here also, and here also it will support multiple bus masters. And the extra features are split transaction, then single cycle bus master handover, single clock edge operation, non-tri-state bus implementation, wider data bus configuration. These are all the extra features. In this, at the end of this this discussion, you will know the clear picture of each and every point mentioned here. Okay, for example, split transaction means, what is that split concept, exactly what is that? We are going to discuss these things. And single cycle bus master handover, from the I think you can get this point. And
consumption of only one cycle from master to slave, like that. It is taking only one single cycle.
No, we know that this AMBA bus architecture will support multiple bus masters, right? So suppose first master accessed that bus. Now the second master wants to access that bus
At the same time.
no, at the same time only one master can access.
Okay.
I think you know the exact figure of architecture. Master, then slave. Between master and slave we have only one bus. Okay, first master accessed that bus. Now second master wants to access that bus, so it will give request to that arbiter. Arbiter will give the access of this bus to any one of this master, right? So first it is giving access to master M1. Okay, so master M1 accessed that bus, it finished its process. Now the arbiter has to give priority to second master. Now second master will take control over that bus and it will do its transaction. Okay, so here between this bus master M1 to M2, what is the time? That is nothing but single clock cycle. You can choose this AMBA-AHB. It provides a very high bandwidth solution. And second is, because a single clock edge protocol results in a smoother integration with the design automation tools used during a typical ASIC development. Yeah, generally there are two kinds of simulators are there: event driven simulation and cycle driven simulation, right? You know that thing. And for event driven simulation, compared to event driven simulation, cycle driven simulations are better, right? In the sense that
Event based are better.
cycle based.
Cycle based.
So this is the single clock edge protocol, right? AMBA-AHB, in the previous slide we discussed that single clock edge operation. So this is based on the clock. So this is cycle based one. So in the ASIC development, if you are using this kind of protocol, it will make our life easier. And the first point, you know, higher bandwidth solution. So if you targeted for these two, if you want to design a circuit in such a kind of situations, then you may choose this AMBA-AHB. And one more thing, it is recommended for all new designs because it is providing very high performance, right? Nowadays we are in system level chip
How is
era.
cycle based protocol or is better than event based?
Anyway, inside a simulator it's going to work in a clock based thing, right? But in the case of event driven simulation in the sense that what? if a particular event is occur, then only it will evaluate the circuit which is
expression it will
yeah,
evaluate the
which is related to that event. Okay, but in the case of cycle based simulation, we are going to have a one cycle, so clock cycle. So it will be definitely it will be in a very high speed clock cycle. Okay, so in that every clock edge it will going to evaluate that each and every part of your circuit, right? For example, this is a event, for example signal A. Okay, signal A is low for some time. At the time of some nanosecond, for example at the time of 10 nanosecond, it is becoming high. Okay, and this is the second signal, not of this A. B is equal to not of A. Okay, now this is a event. If you are using event based simulator, it will check the events. Whenever the change is in A, it will trigger the block B. Okay, so during that time it will come and evaluate that B signal, and it will give the result of that B. This is a event based simulation. But in the case of cycle based simulation, that simulator will going to work with reference to one clock. Okay, so in every edge it will come and evaluate that signal.
But can this AHB be used for event based also? We can use AHB for event based simulation also.
No, it's not like that. We can use in event based simulator also, but in ASIC development, yeah, since it is operating with the reference to clock edge, single clock edge handover and single clock edge operation, it will make our life easier in ASIC development. That's it. And next, if you read the specification, if the signal name is named like this, B, right, means B stands for ASB, and H stands for AHB, and P stands for APB. For example, in prefix, in each and every signal prefix, if you are having the letter P, means that is related to APB bus signal. If you are having H as a prefix of each and every signal, then those signals are related to AHB bus signals. Next we are going to see about AMBA-AHB components. So I think so far we have seen the brief introduction about AMBA-AHB bus and why we are choosing AMBA-AHB bus. Okay, what are all the other buses from ARM Limited? What are all the other buses are available under the AMBA? Right. So I hope you know about AMBA-AHB, why we are preferring AMBA-AHB, and where we can use AMBA-AHB. Right. Okay. Next we are going to see